Welcome everyone. In this video lecture, we will solve a CAT 2020 question which is based on the state equation problem. Okay, so in this question, it is given for the given circuit. So the circuit is given. Which of the following is the correct state equation? So the circuit is consists of one inductor and one capacitor and two resistor and two current source. So here the state variable is the current I and the voltage across the capacitor. Okay, so these two are the state variables. Okay, which is clearly mentioned this I current. So IL, basically we can say this one is our IL. So but in the question it is given I, so I am assuming I. The current across the inductor should be considered as the one state variable, and the voltage across this capacitor will be the other state variable. Okay, and two current source I1 and I2 is the two current source. Okay, so a general state equation can be written as x dot equals to ax plus bu. Okay, so here the variable for the x dash. So in the options it is written into a v I dash v dash I dash. Okay, so here our this should be our v dash and it should be I dash, or we can, if we write in terms of d by dt, so we have to write v I. The same thing is written. Then we have to write a some matrix A with some state variable v I plus some matrix that is our B. Okay, and the current source I1 I2. So this matrix A and B we have to find, and A and B have 2 cross 2 matrix. Okay, so that thing we have to find. So our main thing is to just find the matrix A and B. Okay, so this one is the question. So we have to start. So I'm just using the figure. Okay, so first I'm writing that drawing the same figure here. Okay, so I'm writing the just drawing this figure. Okay, after that what we can do, we have to take the generalized one. Say this one is our. Okay, I have to select the pencil. So I1, better to write is I1, and this one is I2. And now just think this one is ours, say L inductor, generalized one. At the end we will write everything. And this one say R1 and R2, and suppose this one is our C. Okay, so now this current is given is our I, that is our inductor current I is flowing, and this voltage across the capacitor is say V. Okay, so these I and V are the state variable, and for the time being I am saying this voltage is V1. Okay, just assume this one, assume, and this point I am saying this point is say point A, and any point say this point is say B. Okay, so now one more thing, the current I am writing here is say I1 dash. Suppose I am writing this as a I1 dash. Okay, and this current is, I am assuming this one is our IC, current IC flowing, and this one I am saying I2 dash. Okay, I2 dash current is flowing like that. Okay, so now what we have to do at point A, just apply KCL. Okay, so before that, I just want to write the value of L and everything. Okay, so here I am writing the value of L. Okay, the value of L is given, na? So 0.5 Henry. Okay, so and R1 is 2 ohm, R2 is our 1 ohm, and one C value is our 0.25 farad. Okay, this one is known to us. So now what we have to do, just write KCL, the Kirchhoff's current law, at point A. Okay, just write KCL at point A. Okay, so one can easily write the KCL at point A will be total incoming current at that point. That is our I1, the current. This one is the source. I1 equals to one current will go I through the inductor plus I1 dash. Okay, so I1 equals to I plus I1 dash. Now I1 can be written as I current. So no need to worry. I should be I. State variable. We have to write in terms of I1, and I1 dash the current across this one, and we are assuming this voltage is V1. So we can write V1 by R1, or V1 minus zero potential by R. So this one is the one equation we can say. But what should be the value of V? So for this purpose, I am just giving a concept that this one is a L. So the voltage across this one is our, I am saying VL. Okay. And I am saying this one is voltage V, and this voltage is a V1. Okay. So VL, V1 minus V. Okay. So this VL we can write as L di by dt. L di by dt, and VL is nothing but simply our V1 minus V, higher potential minus lower potential, equals to L di by dt. So it's a very simple concept. Then we can write the value of V. Okay, or better to write the value of V1 that is unknown to us. It will be V plus L di by dt. This one is the concept. Okay, we can easily write this one. V1 value is now known to us as a function of V, known quantity V. Okay, I have to use pencil. So this one is a very important one. So this one V1 is a function of V and L. Okay, we have already find. So we have to put this V here. Okay, so now what we have to do? Again, we can write one equation I1 equals to I plus 1 by R1. Then after V1, instead of V1, we have to write V plus L di by dt. Okay. So I1 again I am writing, we have to write step by step, plus V by R1. Okay. Plus L by R1 di by dt. Okay, so in the state equation, what we have to write in terms of di by dt? So better to write one more line, di by dt equals to, one can write minus I minus v by r1 plus I1. Very simple. Just this one, and put all this here in the left hand side, then arrange it. So it should be L by R di by dt minus I minus V by R1 plus I1. So again, why I am doing a step by step? Because it is very handy way to solve such question. Okay, so di by dt and just divide with r by, or which multiply both side with r by l, so it should be cancel out. So it should be written as minus r by l I minus, okay, and this value will be our r1. Okay, so better to write r1. Now in this case it should be minus v by l, minus v by l plus r1 by l I1. Okay, I1. So again, I am writing in more general way, or we can use this one minus. Okay, I'm just highlighting this one. So this one is the one of the equation. Okay, next di by dt, the inductor current I, di by dt equals to minus r by l. Okay, I minus v by l plus r1 by l into I1. Okay, so now at point a we have find the value KCL. Okay, now we have to do for KCL at point B. So I am writing here KCL at point B. Okay, so now we have to write the KCL equation at point P. So take any point P. So total incoming current at that B point, we can say I plus I2 equals to total outgoing IC plus I2 dash. Very simple. Okay, in such question, it is very simple to write the KCL. Okay, now what we can do, I should be I and I2 will be the input current source, one current source, and IC, the current across the C, will be our C time dV by dt. Okay, simple. I am writing Q equals to IT, okay, and Q equals to CV. So if we use CV equals to IT, then IC equals to C dV by dt. So the current will be C dV by dt. So I am writing, and I2 dash. So this voltage will be all having the same potential V. Okay, all having the same potential V. So it should be V by R2. Okay, so this one is the equation. So now we have to arrange this equation. So how to arrange? So just write C dV by dt equals to, we can write minus V by R2. Okay, plus I plus I2. Okay, one more line we can write dV by dt equals to minus 1 by R2 C V plus 1 by C of I plus I2 by C. So this one is the another equation. So I am saying this equation is our, say, equation number 1, and I am saying this is equation number 2. Okay, so two well known equations are there. Okay, so now what we have to write, just in our option it is written the v dash term first. Okay, in the option it is written as d by dt of the state variable. So our state variable is our v, and I. So it is already there. Okay, d by dt. Okay, so then after I just making a matrix here. Okay, and this value will be our v I. We have to use these two equation plus some matrix. Okay, into the current source, that is our I1 and I2. Okay, now we have to put the term for 2 cross 2 matrix, 2 cross 2. So V. So now here what we can say, the V will be minus 1 by R2 C. Then after what we can write, 1 by C. 1 by C, right? As it is. Now it should be I2 C. So 0 and it should be 1 by C. Okay, just think. Okay, it is very simple. Now di by dt. So first we have to write v term. So it should be minus 1 by L. Minus 1 by L. Okay, this term will become first. Then I term. So it should be minus R by L. Okay. Then after in this one, I1 will be R1 by L. So we have to write this as a R1 by L. Okay, and it should be 0. So we have written the state equation. Okay, just arrange these terms and put there. Okay, so now our option in terms of value. Okay, so now we have to find the value of minus. So I am writing minus 1 by R2 C. What is the value? So minus 1, right? R2 value is 2 and C value is how much? 0.25. So if we solve this one, how much it will come? 0.25. So if we solve this one, minus 1 into 0.25, 1 by 4. Okay, so it should be, okay, so I am just writing 25, make it 100. Okay, then 4. So it should be our, okay, R2C, sorry, R2 should be our 1. Na? Okay, we have to solve this one. R2 value is 1. So 1 into 0.25. So it should be 100. So it should be minus 4. Okay. Minus 1 by R2. Okay. 1 by C. 1 by C value. 1 by 1 by 0.25. So it should be again 4. Okay. Then minus 1 by L. Value is 0.5. So it should be minus 2. Okay, then minus R by L. Okay, so it should be something our R1 R1L. Better to write R1L. Okay, otherwise something will know. R1L. Clear? So now R1L. So R1 value is 2 kilo ohm. So minus 2 by L 0.5. Okay, so it should be minus 4. Minus R1 L will be minus 4. Okay, now 1 by C known to us, R1 by L. So now everything is known to us. So what we have to do? We have to very carefully, we have to write the values of each term. Okay, minus 1 by R2C is our minus 4. So better to write 1 by C is our 4. Then minus 1 by L, that is our minus 2, and minus R1 by L. Minus R1 by L is our again minus 4. So write minus, and this should be V and I. Okay, plus 0, 1 by C. 1 by C 4. So better to write 4. R1 by L, but positive. So it should be positive. So it should be 4, 0, I1, I2. So this one is the final result. Okay, I am highlighting this one. So this should be the final result. Okay, so which one is the minus 4 minus 2 4 minus 4? Okay, minus 4 and 0 4 4 0 minus 4 4. So which one is 0 4 4 0 is there, and minus 4 4 minus 2 minus 4. So I know the options, so that's why minus 4 4 minus 2 minus 4. So which one is the correct one? So option C is the correct one, or correct answer for this question. So this is all about this question. So we have to very careful about the step how to proceed, and then we can easily find the answer for such question. Okay, but we have to apply Kirchhoff's voltage law. Oh, sorry, here we are using Kirchhoff's current law, particular point, this point, and any point. Okay, total incoming current, total outgoing. What should be the VL that we have to take care? Okay, so here V1 is the unknown. We have taken this one as a unknown. So how the value of V1 we can easily identify, because this V is given. This V is given the state variable across the capacitor. Vc is V and IL is our I. Okay, so you have to solve like KCL at point A, KCL point B. Then we can identify the two equation. Then in the question it is V dash by I dash. So we have to write like that, and then we have to find the matrix A matrix and B matrix, and in that way we have to write the whole equation. Then we have to find the numerical value by putting the R1 value, R2 value, but we have to careful about the R1 R2. So we can find the value of R means 1 by C minus 1 by L, all these things. And after putting all these thing in this equation, we will get the final answer. So this is the question. So it is quite simple, but we have to very cautious about the steps. Okay, so this is all about this question. Thank you for watching this video.